Let me introduce you to the Earth's core. Below the crust, in the mantle, is a layer of red-hot, semi-molten magma, and beneath that is an inner core with temperatures of about 5,500 degrees centigrade. So you'd hope the crust protecting us from total meltdown would be pretty thick. Well, afraid not. It's only between 25 and 100 kilometers thick. So if the Earth were an apple, then the crust is only about the thickness of this skin. Unlike this apple skin, the crust of our planet isn't one solid surface. If you rolled out the surface of the Earth, it'd look a bit like this. It's made up of a series of jagged pieces called tectonic plates. They come in two varieties. Oceanic plates are found under the oceans. Continental plates are thicker and found under continents or land masses. Heat rises and falls underneath all of those plates, creating convection currents. And those currents can move the plates together from side to side or pull them apart. And it's at the joins, the places where these plates meet, the boundaries, also called margins, that life-changing, landscape-altering events occur. These boundaries can behave in four main ways. First up, over here, Iceland sits on top of a constructive plate boundary, also known as a divergent plate boundary. At constructive plate boundaries, two plates are pulling apart. Magma rises up through the gap in the Earth's crust, forming shield volcanoes and creating islands like Iceland. Over in Japan, an oceanic and continental plate are moving towards each other. These margins are known as destructive plate boundaries, also known as convergent plate boundaries. Oceanic plates are thinner and made of denser material than continental plates. And so when the two meet, the oceanic plate sinks underneath the less dense continental plate. This is called subduction. The incredible force of this struggle causes powerful effects on the surface of the Earth. The devastating earthquake and tsunami in Tohoku, Japan in 2011 were both caused by this process. The same destructive plate boundary has created composite volcanoes that affect Japan and many other countries in what is known as the Ring of Fire. But what about when two continental plates of the same density collide? This occurs at collision plate boundaries. Neither plate can sink, which is why the Himalayan mountain range formed. As the two giant plates push towards each other, the massive pressure makes the Earth's crust buckle. The result? Fold mountains. And that collision plate boundary is still forcing the Himalayas and Mount Everest higher and higher into the air every year. The final kind of boundary is found here in California and is known as a conservative plate boundary. At these boundaries, the plates aren't moving towards or away from each other, but actually moving alongside each other at different speeds or in opposite directions. When the plates get stuck and then finally dislodge, we feel the effects as an earthquake at the Earth's surface. A major earthquake has been predicted to happen in California this century. Even with just a few examples, you can see how over millions of years, these four kinds of plate boundaries have helped to build our world, but also have the power to destroy it.